Hey everyone, and welcome. If you've ever dealt with complex data in your code, you know that keeping it organized is everything. Today, we're going to dive into a really fundamental concept for doing just that: how to get data out of a structure when all you have is a pointer to it. So, think about it. You've got a user's profile, right? It's got a name, an age, an email, all these separate little pieces of info, but they all belong to one single person. So how do you bundle all that stuff together and then pass it around in your program without making these clunky, slow copies every single time? That's the exact problem we're going to solve today. And here's how we're going to break it all down. First, we'll talk about the data bundle itself, what we call a struct. Then, we'll look at the address or pointers. After that, we'll see how to connect the two, we'll introduce the super important arrow operator, and then we'll wrap it all up with why this is a skill you absolutely have to know. All right, first things first. Let's talk about that data bundle. Before we can point to something, we have to understand the something we're pointing at. And in our case, that's a struct. So a structure, or struct as everyone calls it, is really just a way to group a bunch of related variables together under one single name. The best way to think about it is like a physical contact card. The card itself is the struct, and it's got these clearly labeled spots for name, age, and email. It's one object, but it holds all these different related pieces of information. And here's what that contact card idea looks like in actual code. We're defining a blueprint, and we're calling it struct person. This just tells our program that any person we create is going to have a space for a name and a space for an age. We've essentially just made our very own custom data type. Pretty cool, right? Okay, so we've got our bundle of data, but how do we refer to it without having to drag the whole thing around everywhere? Well, that brings us to our second key ingredient, pointers. A pointer is a special kind of variable. See, instead of holding a value, like the number 10 or the name Alex, it holds a memory address. It basically just tells you where to go to find another piece of data. So, to stick with our analogy, if the struct is the contact card, the pointer is like a little sticky note that just has the Rolodex number where you can find that card. It's not a copy of the card, it's just its location. All right, now this is where the magic really starts to happen. We're about to combine these two incredibly powerful ideas. We're going to use a pointer, our little sticky note, to keep track of where our struct, our contact card, is located in memory. And getting this all set up is just a simple 4-step process. First, you define the struct blueprint, just like we did with our struct person. Second, you create an actual instance of it. You fill out a real contact card. Third, you declare a pointer variable that's specifically designed to point to that type of struct. And fourth, and this is the key, you tell that pointer the memory address of the struct you just created. And boom, your sticky note now knows exactly where the card is. So, you've got your sticky note pointing to the right contact card. How do you actually read the name or the age off that card when all you're holding is the sticky note? Well, you can't just barge in. You need a special tool for the job. Now, if you were actually holding the contact card, the struct instance itself, directly in your hand, you'd just use the dot operator. You'd say myperson.age to look at the age field. It's simple, it's direct. You've probably done it a million times. But what if you don't have the card? What if the only thing you have is that sticky note with its location written on it? Well, the dot operator won't work on a memory address. It doesn't know what to do. You need a totally different way to say, hey, go to this address, find the struct that's there, and then get me the value from this specific field. And that special tool is the arrow operator. It's just a dash followed by a greater than sign. It was designed for this one exact situation, to let you access the members of a struct when all you have is a pointer to it. And really, it just makes the code so much cleaner and easier to read. And this right here, this lays out the core difference perfectly. On the left, you have the object itself, so you use the dot. Simple. On the right, you only have a pointer to the object, so you have to use the arrow. Look, myperson.age and person pointer arrow age, they both get you to the same place, but they signal two totally different ways of getting there. Understanding this distinction is absolutely crucial. So, why do we even bother with all this? Pointers, special operators? It might seem like a lot of extra trouble, but the reason is, this technique unlocks some of the most powerful and efficient programming patterns that exist. It's a total game changer. First up, pure efficiency. Imagine you have a massive data object. Instead of making a slow, memory-hogging copy of it every time you pass it to a function, you just pass the tiny, lightweight pointer, or little sticky note. It's incredibly fast. Second, this is the foundation for almost all advanced data structures. Things like linked lists, trees, graphs, they're all built on this exact principle, with elements pointing to each other. And finally, it's absolutely essential for managing memory dynamically, which lets your programs be way more flexible and powerful. So, if you only take one single thing away from all of this today, please let it be this. It is a simple rule that will save you so many headaches. If your variable is a pointer to a struct, you use the arrow. If your variable is the struct itself, you use the dot. That's it. That's the whole secret. And to leave you with a final thought to chew on, the arrow operator is actually what programmers call syntactic sugar. It's really just a convenient shortcut for a slightly longer bit of code. It's actually replacing an operation that involves two other symbols. So, what do you think they are? Figuring that out will give you an even deeper understanding of what's really going on under the hood. Thanks for watching.